All right, welcome to part 3 of managing data in SAS. This is the last part of this section. First thing we're going to go over is explaining the automatic conversion that SAS uses to convert values between data types. And SAS has automatic processes to convert data types where it makes sense. For example, if we said salary equals rate times hours inside of a data statement, and rate was initially set as a character data type, SAS would look at this, and with the mathematic operation going on, it would change rate to a numeric. So that's all that's saying, nothing too crazy. The next thing we're going over is using the input function to explicitly convert character data values to numeric values. So let's create a new data set called table one. We're going to create one variable called column1, and we're going to make it a character value that can be anywhere between 1 and 30 characters long. And then we're going to come down here and say column2 is equal to input, and then our first parameter is going to be column1, and then we're going to say 8 dot, and then semicolon. So all we're saying here is we've initiated a variable called column1, and then we moved on into the next step in our data statement. And now we're saying actually create a second variable called column2 instead of equal to the value of column1, except instead of it being a character, we want it to be numeric. And then let's just add some random data in here. And we'll run it. Okay, looks like we're all good here. So now let's do a proc content so we can see the different data types. Log. And then we can see column1 has a char data type, and then column2 has numeric, just like we wanted. All right. So the next one is the opposite. We're going to use the put function to explicitly convert numeric data values to character values. So let's just cut this because it's going to be pretty similar. We'll paste that in. And then instead of having a character here, we'll say numeric. And then instead of input, we're going to use the put function. And we're going to change it to char 8. Let's go ahead and run that. See what our warning is. Variable column1 has already been defined as numeric, so nothing crazy there. All right, so now you can see this time we started out numeric and we changed column2 to char or character. Okay. So we're going to move on and we're going to explain how iterative do loops function. For this, let's just do an example. A data set called do loop. I'm going to say do a equals 1 to 10. Output. We'll run this, but basically all it's saying is we're using a do function. That's not right, but we're using the do and end statements again, just like we did before. The only thing that's different now is we're adding this a equals 1 through 10, and basically it's going to do this do statement 10 times, and each time that it does it, it's going to increment a by 1. So you can see now we have one variable called a, and we have 10 observations, and it increments by 1 each time. So the key thing here is to put output in between. So that way, each time that it iterates, it outputs the value to our data set. All right. So these next two we're going to kind of do together. So it's use do loops to eliminate redundant code and to perform repetitive calculations. Oh, actually, so that's kind of just like the last one. We could have just used data lines to input 10 observations into our data set, but we eliminated the need for that with the do loop. And then you can kind of figure out based on logic how you could use that loop with different functions and things like that to eliminate some repetitive calculations. All right. And then the next thing we're going to do is use conditional do loops. So in a data set called do loops or do loop, I'm going to say retain a as 1. And this time we're going to say do again, but we're going to say do where now, or do while a is less than 11. So all we've done now is we've added a condition onto our do statement that a has to be less than the number 11, or else it's not going to execute. And then we'll say output again. And this time before we end it, we have to say a plus 1 because we have to force it to iterate sometime because we didn't say a1 through 10 like we did last time. And if you don't add that in, then you'll create an infinite loop where the program just keeps going and doesn't know when to stop. All right, now we'll end it. Let's see what that gives us. Basically, it's two different ways of getting the same result. And then you can create different layers of complexity with different conditions and kind of make the program do what you need it to do, just like most other programming languages. Next, we're going to use nested do loops. It's going to follow kind of the same structure. And just so you guys know, I'm kind of coming up with arbitrary programs just to show everyone the syntax. I know most of these statements aren't necessarily practical, but they're easy for demonstration purposes. We're going to retain a as 1 again. say do while a is less than 11. And now we're going to add another do statement inside the do statement. Say do while a is less than 5. And then force it to iterate. We'll end that interior do. And output for the exterior do. The exterior one to iterate. And end it, and we'll run this program. You'll notice now instead of having 1 through 10, we only have 5 through 10, and then we have a second variable called value. And that's because the program stepped into this statement which said do while a is less than 11. And the first thing it encounters is this second do while, which says while a is less than 5. So a is equal to 1 at this point because we've retained it as 1. And then it says b is value. So it puts value and then it says plus 1. And then does that for the first 5 columns. And then once it kicks out of this, it finishes up this first one, but a is now equal to 6. So it outputs 6, and then says a plus 1, and then starts back at the beginning. But since a is now equal to 7, it doesn't go into this do while and just skips down to this output and keeps on going until we hit 11, which is why we have 5, 6, 7, 8, 9, 10, and value, 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 value. Now we're going to move into transpositions. The first thing we're going to do is select variables to transpose with var statements. And then we're going to combine this next one, which is rename transposed variables with the ID statement. So let's call our data set class scores. We'll input name. We'll say it's anywhere between 1 and 6 characters. And then we'll say score 1 character. And then score 2 and score 3. And then we'll add our data in. And let's just run this to make sure our data works. Okay, looks good so far. We have 2 students with 3 scores apiece. All right, now we'll do a proc transpose statement. And we'll say our data is equal to class scores. And we're going to do an out file called transposed. Oops. We'll say ID is name. And then we'll use var and say score1, and then var again and say score2, and we'll run it. So this is our class scores table, and then let's go to our transpose table. So now instead of having the students on the left side, we have students up at the top as the variable names. So you'll notice that we only have 2 scores, and that's because we only specified 2 variables to include score1 and score2, which is why we only have 2 observations. But if we said var score3, we could add that in there as well. And then you'll also notice if we took this ID name out and ran it again, we don't have any column names. So before it had Trevor and Rover, the student names here, but now it doesn't know how to identify these variables, so it just gives them generic names. So if we put ID name back in, which is the name variable, it knows what to call those variables. Okay, let's move on. Just comment this out. All right, we're going to do the next 2 together as well. So we're going to process data within groups using the by statement, and we're going to use proc transpose options out equals, prefix equals, and name equals, which we've used out already, but we're going to do it again. So we're creating a new data set called scores. Give me a second to get this data all entered in. All right. So we have a new data set called scores, and we have 3 variables: student, date, and score. We have 2 students again, Trevor and Rover, and they each have 3 unique dates, the 24th, the 25th, and the 26th. And you'll notice for both of these, we have 2 entries for June 26th. So we'll run this just to make sure it works, and then we'll move on. All right, looks fine. So the next thing we're going to do is we're going to transpose this. So proc transpose. Let's say data equals scores. And then we're going to use our out equals option and create a file called transposed. And then going to use our name equals option and call it variable, which we'll see where that comes in once we run the program. And then finally, we're going to use our prefix equals option and just call our prefix transposed without any vowels. And then finally for this, we need to also specify let, do a semicolon, and I'll show you why later. And we drop down, and we're going to say by descending student. We're just doing descending because that's how I entered the data, and we didn't do a proc sort. And then our ID is going to be date. We're going to end up first, let's do a proc print. So let's insert. And see what this warning is, just to make sure. That's fine. All right, so this is the data we started with. This is the table that we started with. And this is our transposed and aggregated data. So you'll notice we still have two students, Trevor and Rover, and then we have this variable column, and we have 3 dates, the 24th, the 25th, and 26th. So first, our prefix equals option is what gave us this in front of these 3 date variables. And that can be useful just so, I mean, for a variety of reasons, but in this case, we labeled it so that we know it's transposed. And then our name equals option gave us this. And if we took that out, I'll show you what it would look like. Kind of serves the purpose that the ID statement works. It just gives it a generic name otherwise. Keep that in there. And then this let statement we need in there because we have 2 entries for June 26th. So with let, it tells the program to let itself just use the last observation if there's multiple. So that's why we should have 97 and 87 on the 26th. Yep. And that's that. So we're going to move on to macro variables next. So first we're going to create macro variables with the percentage, I don't know what that's called, but let statement, which is pretty simple. All you got to say is let, and then type what you want the stored procedure to be. And it doesn't necessarily even have to be a procedure, but we can say, or sorry, I don't mean procedure. You're creating a variable that should be stored. So we're going to let student be equal to Trevor. We'll save that. And we'll end up running it, but the next thing we're going to go over is use macro variables within SAS programs. So if we wanted to use that student variable that we just created, we would say data, and then macro table, say student name equal to percent student. Go ahead and run that. Student name, instead of it being ampersand student in here, it's the value of the variable. So Trevor, just like that, nothing too crazy. All right, that's it for this video and for this section. I'm hoping to do the next section, which is error handling, soon, but let me know if you have any questions.